Please note that I have edited the original video to remove what I think is not relevant, and it took the original presenter a long time to get to the point. I have made a sound showing where I have edited the original video. There is a link to the original video in my crotch.
Hello, YouTubers. This is my first flat earth video.
Gosh, I hope there's so many more to follow.
And I wanted to see if I could prove if the sun travels at the same speed around the earth in the summertime for the northern hemisphere and for the southern hemisphere.
Actually, a minor point, you want to disprove that. You don't want to prove it. You want to disprove that the sun travels at the same speed across the sky for the same latitude in southern hemisphere and northern hemisphere. You don't want to prove that. You want to disprove the hypothesis. Scientists disprove, they don't prove.
What I did is I found two cities in the northern hemisphere on June 21st. That would be the summer, so that's the longest day of the year in the northern hemisphere. I wanted to calculate miles per hour the sun moves, and I wanted to calculate the miles per hour in the southern hemisphere on their longest day of the year, which is December 21st. Okay?
Otherwise known as the solstices, where the sun appears to go north or south and then back again on a flat earth.
So let's go ahead and shoot. All right. So here we have Bourne, Texas, at a latitude of basically 29.8 degrees north.
Please note the longitude also. This becomes important.
And St. Augustine, Florida, also 29.8.
And note the longitude. I will agree, for the sake of argument, that the latitudes are close enough.
Degrees north latitude. So we got the same latitude. I figured out the distance between the two cities right here, 1,044 miles.
Aha! Jack Aubrey! I have you there! And if you don't understand the reference, you really need to read some books. 1,044 miles, Great Circle Route. What part of Great Circle don't you understand? The great part or the circle part? Rumline, 1,131 miles. Great Circle, 1,044 miles.
On the same latitude. And here's the sunrise for Bourne, Texas at 6:35. And here's the sunrise for St. Augustine on June 21st, the longest day of the year, is 6:25.
Dude, look, I'm sorry, I'm choked up. Look on your webpage where it says the words sunrise. Just below it, it says sunset. On a flat earth.
So I went to my spreadsheet and I put in the sunrise for both cities and the distance, the amount of time difference for the sunrise is 2 hours and 10 minutes.
On a flat earth, the difference is 10 minutes. You subtracted 2 time zones, dude. Why do you suppose you had to subtract 2 time zones?
By the way, you should have only subtracted 1 time zone, not 2. A simple check shows Central Time compared to Eastern Time. 2 hours? No. 1 hour? Yes.
Hours, so 2.16 hours, and the miles between the two cities is 1,044. So I just did simple math and did it. The sun travels 1,044 miles in 2.166 hours. That's 482 miles per hour.
No, using your method, 895 miles an hour.
Okay, South Africa. We have Springbok, South Africa. They're at 29.6 degrees south latitude, which is very close to 29.8. And the distance to Durban, South Africa is 29.8 degrees south latitude. So all four cities on the northern hemisphere, 29.8. On the southern hemisphere, it's 29.8 degrees latitude. So I figured out the distance between the two cities, and here we go, right here.
I just checked, they do use the same time. No time zone change.
The distance is 788 miles, and I calculated the sunrise for South Africa on the longest day of the year, which is December 22nd or 21st. So the sunrise is 5:45 in Springbok, South Africa. The sunrise is 6:51 in Durban, South Africa. Okay, so there's boom, boom.
It is not easy to see on this screen, but he is showing two lines between the distances. One is a rhumb line. One is a great circle line, which one would expect on a spherical Earth. Guess which distance he is using between 2 points? That's right, the great circle one.
And if we go to my spreadsheet and the southern hemisphere, so right now we have sunrise 5:45. Sunrise in Durban is 4:52. That turns out to be 53 minutes between these two cities.
And as I noted, there is no time zone change, so he is correct.
The distance between the two cities in miles is 788 miles, and 53 minutes converts to 0.8833 hours. So simple math, we have 788 miles divided by 0.88 hours equals 892 miles per hour.
Compared to 895 miles per hour in the northern hemisphere. If you do the math correctly, and you note, is one time zone difference between St. Augustine, Florida, and Bourne, Texas, not two.
So if you're going to calculate the miles per hour in the northern hemisphere, we have 482 miles per hour.
895.
From here to here in the northern hemisphere, and it would make sense that for the sun to go around the northern hemisphere, the sun would travel slower. So we calculated 482 miles per hour in the northern hemisphere on the longest day of the year in the summer, and for the sun to go around the southern hemisphere in their summer, or our winter in the northern hemisphere, we calculated 892 miles per hour.
If you do the math correct, and if you do the time correct for local mean time, it's 2.78 miles per hour difference.
So according to my calculations,
you added a superfluous time zone.
It's proving that the sun is actually moving faster in the southern hemisphere compared to the northern hemisphere.
Your miles per hour difference is less than 3. Let us assume that your erroneous time problem was not there, and the sun really was going twice as fast in the southern hemisphere as the northern hemisphere. What mechanism is causing that? What are the physics involved in speeding up the sun in the southern hemisphere and then slowing it down in the northern hemisphere. What mechanics are doing that? How is that happening? If your video proved, and you used the word proved, that the sun is a whole lot faster in the southern hemisphere than the northern hemisphere, and when we take into account that you got the time zones wrong, doesn't that prove your word that the sun is going the same speed in both hemispheres? Doesn't that prove your word that the Earth is not flat?
So I think this is one for the flat Earth community. If there's any mistakes, please leave them in the comments below.
He asked people to give comments. If he had not asked people, I would not have made this video. So he asked, so I made this video. I have a question. I'm not going to use your real name because that would be too forward of me, too familiar. I will just call you Dude. Dude, if your conclusions are contrary to all of the real scientists out there working in the related science venues since the year 1560, and all of those scientists concluded the same conclusion, and your conclusion is contrary, I have 3 propositions to you. Number 1, all of those scientists for several hundred years are wrong. Could happen. Number 2, all of those scientists for that many years have been deceiving and lying to us. Number 3, perhaps you made a mistake. How is it possible that you thought either 1 or 2 was correct and not 3?
This is my first video. I'm a little excited that I calculated this because I wasn't sure what the answer was going to be, and it looks like it's what I thought it would be. So anyway, thanks, and talk to you later.
And by golly, you're the first person out there to think of this, and you're the first person who did the math, and you're the first person who discovered that the sun is going almost twice as fast in the southern hemisphere as the northern hemisphere. How likely is that?
Everyone in this room is now dumber for having listened to it.